Okay, let's start with the second part of the training related to the starter kits for users, developers, and it will be a combined presentation where when we will have moments of, let's say, theoretical approaches, we will have moments of screenshots, and we will have moments of live demos. So, well, for the live demos, you know, we expect everything to work, and we have backups in case, but uh, we will alternate between Daniel and I for the hands-on part. So we are starting this part, and we have oriented this starter kit for users, developers, and admins. I will say that the difference or the intersections between some of the things that we are going to explain here are gray. It's not so putting a border where an user ends and then a developer comes and an admin can be a little bit trickier. So maybe you will see similar content, but from different angles. We have considered a user, a person who is producing data, metadata or a service, and want to make a general use of the Inspire Reference Validator using the UI. So this person runs a test and obtains a result acting in consequence. So we find a failed test, then we have to fix it. We have to investigate why is it failing, and then we have to fix it and pass it again and again and iterate until the test passes the validation. This is the purpose for users. For developers is a little bit well, it's quite different. We have considered to be a developer someone who is dealing with the product, who is dealing with it at a low level, not only deploying but also wants to understand the whole setup, the architecture we have seen before, but operating it, and not only wants to understand the components, but also the source code, and in case to contribute to perform any improvement in the source code and contribute to it. So as part of the explanations on how to understand the components and the architecture of the Inspire Reference Validator, we will also have how to deploy it, but also how to code and how to build it from the source, creating your own package and creating a workspace in case you want to adapt it or to customize it to your needs. At this point, if you are also a developer, we have also considered a developer someone who is also skilled in technology, but also wants to create some scripts in order to use the API. So if you want to perform some validations using the API and you want to program a Python code to make this request and execute this test and obtain results and iterate, you will also have an overview on how the API works and also the API gateway. And finally, if you are very, very, very skilled and you obtain an error and you want to go through the ETS to see if the validation is correct or according to what you consider from the technical guidance and you want to get into that level, we will also show a little bit on how the ETS are structured and a little bit of example of where the code is placed and read together with you what the code is doing. We will alternate between Daniel and I, depending on the part and the content to share with you. And finally, we have the administrators who we have considered here to be the people who is deploying the Inspire Reference Validator, starting from the Docker deployment that is provided in each release. So we will make a tour on the Docker components, the zip file, folders, how it is organized. We will At that point we will be very aware of the architecture, but we can revisit it in place in case, and show how to build, how to deploy, and also how to customize this deployment to your needs. We have faced some issues, and we have feedback from the community. For those of you who want to deploy the ETF, sorry, the Inspire Reference Validator in your premises, and you want to deploy it in a certain domain or with a different name, not validator but validator my organization or my validator or whatever. So we will also cover where to configure it, so you will know how to deploy it. Well, again, this is the timing is an orientation, but there is no problem because this session will be recorded, and the training material together with the presentation will also be made available. So let's get started with the user part. We assume that all the people here in the room is is familiar with the Inspire Reference Validator, but just in case, let's make a quick tour. This is the Inspire Reference Validator. You know the home page, and you know the different parts we have here. We have this welcome page, this landing, where you have an introduction on the fundamentals of the validator. You can go to the what is an ATS. You have the origin, and you have a first point where you are pointed to how to start a test. You also have the part for the API. You have the part which is what we have considered developer, and the part of the download of the software, so you can deploy it in your premises, mainly for admins. And finally, where you can provide us with your feedback, the community space on GitHub, where you can put an issue there, and we will provide you with feedback. Said that, we have the test selection part, where you can choose between data, metadata, or data services, depending on the kind of service that you are validating. You will be able to configure it. You can have these advanced options where you are choosing which conformance classes are you choosing to your validation, and you will face the CAPTCHA uh, in order to provide you with the capabilities to upload your own file. Okay, so said that is well, once you sorry, press the wrong tab. Once you run a validation, you will be prompted to a new screen where the validation will take place. In this screen, you will have the access to different parts, which are the report, saying in which part the validation is fine and where it isn't. You will have also the log files available, and you will be able to download the report in case that you want to have it there. Also important to know that you can rerun the test in case that you are using, for example, a service or a concrete file, and you don't want to configure every time the same conformance classes to validate. You have the run test where you are prompted again to introduce your data, or the info to be validated, and then the test will be run accordingly. For the test report, I'm sure that you have seen it before and you're familiar with it. You will have conformance classes, and you will have all the tests that have been performed and how the information has gone. If it has passed, if it hasn't, or if it has anything that needs to comply with information in order to provide you with some input for you to align the test. Then we were talking about the laws. Well, this is more for developers or for better understanding what has gone on. And finally, you have this test reports overview where you have all the tests that are ongoing. You have all the tests from the community, and you can see how they are going. This is the production instance of the validator, by the way. So said this tour, we wanted to go for an example where we wanted to move from a failed test run to a valid test run. The information that we are going to use at this point is available in a specific training folder where you can access there. Let me quickly go to it. But it's not pretended for you to be, let's say, you don't need to do it on. It's not a workshop where you are required to be doing things at the same time. You have it here. You can do it again. You can better follow it with the video and the slides, and you can find the material here. Okay. So first we are going to move from a failed metadata. We are going to make an exercise where we are performing a validation on a metadata, which result will be failed, and then we will fix it. It's a simple case just for you to understand how to operate, and we will finally run through to a passed metadata. So this how we will operate will be selecting. So let's go into the thing. We want to validate this metadata. You have here the link if you want to go directly to it. So you will find it in the slides apart from what I've shown. So we choose the metadata, choose the version, choose the conformance classes that we want to test, and upload the file. Okay, in this case, this is the one to be uploaded. As we do not want to overload the production instance, we run it in the coffee break, and we have the results available, so we can share it with you. But assume that you have already uploaded the file, and it is available there. So we have this metadata. We have it here, and we see that this is failing. Oh, why is it failing? So we need to have a look at it on what has failed. We go to the test report, and we see all the conformance classes and all the ETS that have been executed. We navigate through it. We see the ones that are fine, and we see that there is a general requirement that is not met. So we go here, and we start reading what has on, and it says test has a resource language is giving point to one official language of the community. So well, we have this first message, which comes from the ATS, and we have a link to provide us additional info on the ATS on what is missing and details on what should be present in the metadata. So here it says that for this validation there is a metadata language field that needs to be there, that has to comply with the code list and with one of these values. So at this point, everything after this, let's say, quick investigation, everything should be more or less clear on in terms of what is missing or not in my own metadata, and will be in condition in the moment to fix it. So what we are missing here is now the part where um, we fix the metadata. Let me check 1 second because I have it here in the. I'm going to share my screen, and I would like to put the old metadata where we have this old metadata, and we see whether we need to include I'm sorry, this is the passed one, this is the fail. Perfect. So in the fail we have our metadata. This is a simple one, and we see that we have different places with the tags. And in line 13 we have on purpose deleted this requirement, which was the one related to the language code. So it is not present in this metadata at all. So at this point, we will now have, starting from this, from the metadata that we have uploaded and that we have failed, the information that has been provided by the test report, which is here, the context provided by the ATS, and our own knowledge of our own metadata, would know how to fix it. So now we have missed this part to be included. We forgot it somehow, or it is not automatically generated by our application or whatever, and then we need to include it according to the requirements set here in the ATS. So now what we include is the language, saying where the code, which is the language and the code list where it is taken from, and the char set also needed in order to understand how the codes will be interpreted by the validator. Once we include this, we are now in the position of validating again. And this iterative process can be done again and again and again until we align the result of the validation to our needs. So once we include this language, we save it and we go to perform the test again. We follow the same procedure. We choose the metadata, we choose the 2.0, the conformance classes that we want to execute, and then we run it. As commented before, we didn't want to overload the production instance, so we have done it before. The metadata is here and it's available in the repository, so you can have it, and you will see now that the report is here, and the requirement now is compliant, which is this requirement and has passed. So this will be the process that you will need to follow. This is a quick starter, a quick proof of concept on how to do it for a metadata. Issues can be more or less complex depending on the complexity of the metadata, the organization, and so on. But the process to solve it will be the same. So now we want also to exemplify another example regarding another theme, which is going to be a little bit more trickier. It is going to be about a data set, which is going to be building and it's going to be a building 3D. Here we choose in order not to overload very much, we have gone the same way than before for the buildings. And we have chosen the conformance classes. We will go here, we go to the repository, and we will include the GML. And once we have here, we have a training, and we have a passer manual. Because the result of this GML that we are processing will be a passer manual. Right, then we will start the test, and we have the report here in order to show you. We did not want to give to provide issues. Now what we want here to exemplify is not only the uh, not only the process, but also the relations between between the validations and the external dependencies. And now we are failing a validation which is related to a code list which is present in the registry. Okay, so here we have the validation, and here we have the result, and this code list is the one that is failing. We have this here, and we have the original metadata. Let me share the screen again. I'll move the file here. Okay. Okay. So we have the information provided by we have we have the test report, and we have the information of the field test, and we say that all the current use has a link, an attribute to a predefined value that needs to check if it is available or not. And again, we have the link to the ATS. So, sorry, uh, sorry, I didn't check the right one. So there it says that we have a list of validations that need to comply, and the multiplicity and additional information that we need to go there and visit and see what is exactly missing. So this is a typical case where the issue is not on the content but in the format, because what we have done here is that now we find that we go to the ATS, we check all the documentation, and then we go to our metadata to see what has gone on, and we see a slight difference between what should be there and not. This thing happened. This is not a real case, but a potentially real case, because the issue here, you can see, is the value that we are using. It's in plural and should be in singular. So in this case, we find that the error is prompting us that the URIs of the registry comply with it. And if we go to the registry, we can see that the residential that we have is not available. You see that this URI doesn't comply. So we start digging, we go to the documentation, and we see that the residential is complying. So we find out that finally what is actually wrong in the metadata is this. which is what the error message meant regarding the URI and the S at the end of the URI. Well, it has slight change, but these kind of things happen, and the concept is that the URI was wrong, whatever is needed, and needs to follow certain rules, and also exemplifies the coordination with the registry and the use of it. So here we modify our metadata. We go again to the validator, and we pass again the validation. And let me check. We pass again the validation. We go there, and we have that this it was, sorry, application schemas. Code list. Now we see that the current use, that was the one complaining before. Let's see the before and after, is working fine. We have the same information, but we see that where it said before that this URI is not compliant, now we find that the test has passed. So with this quick overview on how a user, potential user, can operate, we wanted to give you this couple of examples, these hands-on examples, to for you to have an idea on how it works and how the validation goes. I think that most of you are familiar with this process, but in any case, it's good to, we think also it is good to have it there. One more thing to say, that we will continue with buildings in the next slides, also in the developer part, where we will go into how to create an ETS, and we will go into the definition of a rule. Well, we wanted to have everything more or less in the same with the same context. So continuing with the presentation, here you have the screenshots in order for you to know where these errors were. But we have done it a little bit on the fly, and you have finally the metadata. You have the before and after. Again, here to reinforce the fact that the validator is using the ETF and the API, and the UI is showing the same than in the ETF. Then to clarify, then moving on topic, we are now moving on to the part where we want to provide you with a little bit more of insight on the use of the API, as we have commented. This API of the validator is used by different parts of the UI. If you see here, test report, C report, even the start test or the delete report are remote calls to the API. These calls are available in Swagger, an open API context, and you have lots of examples to complement your own deployment. You can see them here. Just to finalize this exemplification, that you have the test reports, and you have that all the calls that are here are made to the API. Okay, so I hope the exercise has been illustrative for a user perspective on how to fix a metadata. You have the information available. and also how to fix a code list in a data theme. Now let's move into the developers part, where we want to start with the understanding of the ETF setup in 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 context, in order to provide you with the basis to the and continue the explanation. First thing we want to go a little bit deeper is the setup of the whole infrastructure. We mentioned in the previous slides that we were using the UI to make the requests, and then the Apache will deal with it, and then it goes to the ETF, and then it makes things and reply back the test report. We want now to go a little bit deeper into it. As you have seen, the UI uses the ETF API, but this UI and this ETF API can be used in a massive way and can harm the production reliability and overload. So in this case, we have created an API gateway. So when you are using the UI or you are calling the ETF, it is passing through an API gateway and it is getting to an Apache. This Apache analyzes the request and redirects it to the ETF. The ETF now, in this first request, what has is the configuration of your test and your data to be checked. So starting with the configuration of your test, you have configured that you want to run certain conformance classes. The ETF goes to the repository of the ETSs through the corresponding test driver. So it gets here and gets all the validations present in the ETS. This ETS comes back and together with the input that has been provided starts to be launched and goes conformance class by conformance class. At this point, it is the content of the input data provided is analyzed, and external resources are probably needed. If you remember, we were using code lists for the buildings theme. So these code lists are available externally. So we make an external request. In a normal operation, the external request will go directly to the source and come back. But as you may have noticed, you need to validate a lot of code lists and a lot of application schemas. So, for example, in the relation with the registry, we will provoke a simple validation will provoke tens of requests to the registry and eventually cause a degradation of the service performance. So if we have, for a simple metadata, for example, 20 calls to the registry, and it starts to spend 1 second in each of them, a simple metadata could take longer than a minute. 20 calls, 20 seconds plus processing and so on could take a minute. So in first instance, what we made was to put a reverse proxy, which is quit, and acting as also as a cache. So all the requests to external resources are cached after the first time they are requested. So then the response is immediate for the ETF. Instead of seconds, it will be milliseconds, and the performance of the whole validation will improve. This is a first important thing to notice about this reverse proxy that is here. The second one was also mentioned before, and it was regarding the limitations that the Java and the ETF has regarding to the redirection. Here, if we put an HTTP URL that is not available and it's redirected to an HTTPS, then Java is not available, is not allowed to handle that redirect for security policies. So either we modify the code in the ETF or we put something in the middle. The thing was, the problem here, I'm telling you now we are in the developers part, that the ETF is using different libraries and is relying on libraries to perform the XQuery, to open the XMLs, and to handle with the redirections and so on. And this is an external dependency on the libraries itself. So it was analyzed. There were in a technical committee following the governance process. We decided to analyze how to handle with the redirections. We saw that it could be interesting to make a wrap on the different libraries, but it presented some technical issues. So finally, we decided that together we decided that it was not possible to modify. It was better to modify externally this redirection, to address this redirection in an external way, than doing it in the source code. Because it presented problems of compatibility, the capacity to be updated if the external library was updated and the method changed or whatever. So we prefer to have a separate component to handle this redirection. We studied different things, and we took the chance that we had already an external element here acting as a reverse proxy, which is the squid, which was initially meant for cache purposes, but also made the trick for this. So when you make the HTTP request, here squid makes the change from HTTP. For it has some rules defined in order to make these redirections, and the request is it to Apache, who is the one in charge to make the actual request, go to the registry or to that HTTP place, receive it now. Sorry, here it is made the redirection. It requests directly to HTTPS, returns, and it is cached and returned to the ATF. So here we have dedicated some minutes to it because the reasoning of this component on the architecture is needed for these two reasons: cache and also the handling of redirection. Okay, said that, we have a very good understanding, hopefully, of the ATF. And now when you have all the resources, coming back to the use case, we have the test case being, the test report being executed here, all the resources ready, all the rules ready from the ATS, all the data ready from the input. We have everything there, and the ATF finally creates a test report that is returned to the user through the ETF API. So now that we have this understanding of the architecture, which is needed for developers and admins, let's go to the next part, which is related on understanding a little bit more the internal architecture of the ATF. Then we will tell you how to deploy the ATF, only the ATF, and then how to manage it, which we call the building it from the source code, and how to create the workspace. So now, Daniel, we move to the next slide, and I don't know if you prefer to share yourself. One second. So I will share the screen, and Daniel will also share. So we have the folder structure here of the ETF web app. When you deploy an ETF, you find in your deployment location the folder structure, which has some relevant components here. Okay, these components follow a folder structure which is determined, and we wanted to highlight the main places that you need to look into in order to understand what is run and what is produced by the source code. So when you execute the ETF and you have the source code, you go step by step, and the test reports are stored at this level: test runs, the test run, libraries, and the rest of data. So now Daniel will share the screen and detail a little bit more this.
Yeah, hi. Okay, so just as Enrique said, any of you that has deployed the validator on a local instance would know that it creates a folder in your home folder called ETF, in which the validator stores and saves all the data it used in order to create the test report. We will see each of these folders individually and see what it is stored in each of them. First, we have the validator folder, in which the UI for the validator is saved and all the HTTP part of it. Next, we have the test data, in which it is saved all the files the user uploads to it to test, and we can see the file it is uploaded. Next, we have the TD folder, which I can't get it in because it needs sudo permissions to get, but it is where all the test driver, like the swap UI test driver or the base X test driver, it is stored for the ETF. Then we have the projects, in which will be saved the ETS that the ETF uses. We can see any of them. It will be the assets the ETF will use to test or data or space data. Then we have the logs, in which the ETF log will be saved, so we can check if anything has gone wrong, why it has gone wrong. Then we have the HTTP uploads folder, in which will be saved the external services the user want to test instead of a local file. If it wants to test a external service, it will be saved in here, which doesn't appear because these files aren't actually external, are from our local machine. In the DS directory, we can find the internal data ETF has used to test the services and the results of them. For example, yeah, here we can see one of the asserts the ETF has done for one of our files. Then in the config file folder, we can see the config properties for ETF. We show the properties it will be used on our local instance. And last, we can see the back file will be where some files will be saved after the ETF deletes them. As you may know, ETF deletes test reports and test files after a time we set on our local instance. When they are deleted, some of the data will be saved on this folder, so it is not permanent delete. And that will be all for the ETF folder that we will be visiting later in order to see some more parts of the ETF and validator.
Okay, thank you, Daniel. Well, we have seen now how the structure of the ETF folders and which is the more relevant part that are to be considered for the development. And now we move to the part where we want to exemplify how to deploy the ETF using Yeti. Here, what we have commented before, there is the ETF is based on Java. It runs on Java 11 and Yeti 9. And here you have the environment that you need to have at your premises in order to be downloaded. So you can put the exact setup in your premises. So first we will need you to download a Yeti server. Then we will need the Java 8 for this version. We are using Linux 1. And for the Yeti, well, we have the zip downloaded from the repository of GitHub, and inside it we have the Word file. So now let's go live again and see how we deploy.
Hi again, now we will see how to deploy a local instance of the ETF on a Yeti server. First of all, we will need to download Yeti. ETF recommends us to use the version 9, which will be the one we'll be using. And we will also need the Word file for the ETF. Once we have downloaded these two files, we have it on our folder, we will extract the Yeti zip, and we'll see it has lots of folders. What we'll have to do is to get this one and copy it outside. We will rename it to Yeti base, and we will delete these files because we really don't need them, because it is some examples Yeti comes with to test it is going all right. Now we get the Yeti started file, and we move it inside the Yeti base folder. Sorry, I'm wrong. You should be seeing it now.
Yes, we do. Thanks.
All right. As I was explaining, sorry, we have to download the zip file for Yeti 9, which we can be found in the Yeti official webpage, and the Word for the ETF web app. I will be explaining again this, just so everyone gets it. Once we get the zip for the Yeti 9 version, we can extract it anywhere, and we will be needing this folder. We can copy and paste it outside, and we have to rename it to Yeti base. Once we have it, we can copy and paste the Yeti distribution file folder. Sorry, here. We can open the web apps folder and delete all of this because we don't be really needing it. Now we will need to do is copy the ETF web app URL and paste it on both web apps folder inside Yeti base and Yeti distribution. Now what we have to do is go to our Yeti base folder and use this next command. In which we'll be saying to the Yeti server to open our web app, the ETF web app, on our local instance using the web version here. There we go. It is loading the ETF, and it will be soon be loaded. Okay, once we see this last line, it means it has fully loaded, and we can go to our local browser and open our local ETF instance, which should be on our local host on port 8080. If we go to our port 8080, we can see the ETF web has been deployed on this relative path, and it loads. As we can see, we have no loading ETS on it, and we'll be discussing further how we can deploy our ETS directly on our ETF local instance.
As commented here, you have all the steps that Daniel has just shared with you. How to deploy it, how to start the Yeti, and then finally how to get into it. As he has also commented, we will get later on the main parameters to configure the ETF in the part of the admin part related with the Inspire reference validator. Then we are moving in this developer part on how to build the ETF from the source code. As we have commented before, the ETF is available in the repository or in a public GitHub repository. So it follows a standard procedure in order to download the data, which is cloning the repository, and then you have there. Once you have selected the branch that you want to build, you have to build it using the instructions that have been provided using Gradle, and once this Gradle is executed, you finally come with the ETF web app ready to go. At that point, you will have the Word file of the ETF, but then depending on the ETSs you want to install, you will also need to include or to make sure that the different test drivers are included. So if you are using ATS based on base X, you will need to include the corresponding test driver. If you are using ETS based on SWAP UI, you will need to use this test driver, and which is our case for the three of them. If we are using resources in the ETS which are coming from the team engine, we will need the team engine test driver. TD stands for test driver. So with this requirement to compile, to build regarding Git, Java and Gradle, we obtain the Word file compiled. And now again we are exemplifying this process live. So Daniel, please.
We will be using the commands we have seen in the presentation to see how we can build the ETF with the source code. So if we want to do any modification or rewrite any code on the ETF, we can download the code, modify it, and then build it in this way. First, we have to clone the repository from GitHub with the command, and we wait for it to download. It's pretty fast, and then we have to get inside that folder. Once we are inside, we have to run these three commands using Gradle. Then we use this one. And once it is finished, we can use this last one to finally build it. All right, well, once it has finished the whole process, we can see that inside our ETF app and all of these components inside the ETF web app, there is a new folder called build in which we can find our ETF web app.war inside the libs folder. This is the same where we have used to deploy the ETF on the Yeti server. And if we have to do any configuration to it, we just have to rewrite the code, build it like in this way, and just use this word instead of the other one.
We are starting to make it more complex. We are following an incremental approach in, let's say, in complexity, depending on where you are more comfortable or what are your needs. We have started by downloading and deploying the ETF in a Yeti server as it is. You only have to touch configuration parameters. Then we have followed on building it in case you want to use a specific configuration for this build of the product. And now we are going into how to develop with it, to actively develop um, with the the ETF, the source code. So for this purpose, we, as part of the processes where the Inspire reference validator is contributing to the ETF project, there has been the need to create some functionalities or to modify or to adapt some source code. And also for debugging and testing purposes, because sometimes the issues are quite deep in the code and it jumps from library to library, from module to module. So we have found necessary to build a workspace. After analyzing different tools in the available, we use Eclipse, we use NetBeans, a lot of tools for Java. We Visual Studio. We have finally came with IntelliJ, which was the option used by the developers, by Interactive Instruments. It was also our recommendation for you to have. But you can use whatever tool that you are comfortable with. But I have to say that it's not an easy process at the beginning. So IntelliJ for us is also following also the recommendations from Interactive Instruments is the one that we are using. So we will now explain how to create our workspace. in IntelliJ. So you will need to download IntelliJ and install the Java and Tomcat plugins. Here we are using this Tomcat plugin instead of Yeti because it works very smoothly and makes us available to being able to call between different components and create remote calls in order to debug. So first thing you have to do is to install the proper configuration plugins, Java and Tomcat, and then to create a Gradle project. As you have seen before, the product is compiled and created built using Gradle. We will go live after sharing the approach in the screen, but we want to share it with you in advance. After you have the Tomcat app plugin up and running, you need to create a configuration file for the different modules, and this is important for you to know. Here we are creating the one based on the ETF web app, but in case that the debugging gets deeper or affects different modules, for example, the test drivers, you will need to create a specific module configuration for each of the components. So you have the Word file, you have the different jar files, and the way to debug it will be by creating external calls to the specific component. So when you are jumping from when the source code, the execution is jumping from the ETF web app, for example, to a Team Engine test driver, you will need to have both of them here in the web app, sorry, in the configuration, and you will need to make the remote calls from one library to the other, for one component from one jar to other jar, or from the word to the jar, and so on. And before passing to the live demo, to Daniel again, to tell you that this, as everything that we are commenting about the ETF, you can find detailed documentation that we have produced for the ETF, one of the contributions. So you will see here what we are showing can also be consulted either in the presentation or in the official documentation of the ETF. And now it's your time, Daniel. Let's move to the live demo.
In the ETF using IntelliJ is pretty easy. We have here open one, but we are going to get it again from a new repo, which we open the get from version control, and we just have to input the repository for the ETF Validator web app. And we have to set a name for our project. It will start loading it. We select Trust Project and open in this window. Once it opens, we wait for it to fully load. And once it loads, which it seems is finishing, it has fully loaded, and we can open Gradle for IntelliJ from this right button. And in tasks, build where we can double click and it will be built just as we did before. Now it has fully completed the process to build it. We can go here and edit a new configuration for the ETF to upload with the Tomcat. We select a new configuration and we select our Smart Tomcat plugin that we just downloaded. We have to select a Tomcat server, which I have one just here. Didn't get. There we go. And once we have configured it, we can select apply, OK, and we can upload it directly. And as we can see, it is getting the same log as we had before, so it will be just be uploaded on port 8080, just as we did with Yeti server, sorry. And as it is the same result, we don't really have to get on all of the details of it. Okay, that will be all for how to deploy the ETF on a Tomcat instead of IntelliJ.
As also Marco has commented before, in the interest of time, we will cover the content with the slides and keep an eventual demos with the question and answer part. So once we have covered for the development part how to deploy a workspace and so on, we wanted to emphasize the use of the API. This is important in order for you to integrate and to use the validator. So as we said, there is a Swagger in place. We have already visited it, and there we have different calls, and we have different calls that are relevant in order to create and to run a test using the UI, sorry, the API. First thing is to upload the resource. Here is the call that you need to do. It is exemplified in Swagger. Then once you have uploaded the resource, you have to start this test with that resource associated, and after that you can check the progress with the ID. Then when you start this test run, you are provided with an ID for your test, and then you can consult how the status of the test is progressing, and finally you can get the test results. And this use of the UI is in what is based the whole, let's say, the whole architecture of the Inspect reference validator for the ETF. Okay, so this is about the UI, the theoretical approach, and then here we have some screenshots on how to do it in Postman. If you want further details, we can extend a little bit on this, on the question and answers, but this is only to put here the kind of request, the endpoint, and the information based on what Swagger has already provided you before. This is straightforward, and it will be, I think it will be easy for you to accomplish this. Now we come to the API gateway. As we have commented before, the UI is using the ETF API, and but it can be done remotely and with processes, with Python, or with external tools. So in order to limit the workload that can be eventually provided to the production instance of the Spire reference validator, just to let you know that there is an API gateway. So this API gateway is in place to avoid the massive use of the production validator. Nevertheless, there are some users that cannot deploy the validator in its own premises and still need to use the validator in an automated way. So for those users, the API gateway is in place, and they can be provided with an API key limited to 200 requests per week. You have further details in this issue in helpdesk on how to request and obtain an API gateway. It's an easy process where an email is sent, is validated, and you will be provided back with the API key. There is also an interface to provide how your use goes and which are the tokens that you have left, which is in this URL with your API key. You can consult how much have you used the API key that day and the remaining uses. In this case, you have got to 0. On Sunday, you have been refilled. On Monday, you have done nothing, and the user has used 176 requests on Tuesday and has 24 remaining, which has later used. And then a disclaimer: we have commented that it is not the ideal to make this use of the production instance of the validator, and we encourage you to have your own instance of the validator using Docker, and we remain available for you if you need any help with the deployment. Then I'm going to be quick on this on how to develop an ATS. As we have commented before, there are the technical guidance, which are the requirements that the datasets and services need to comply, and from that the ATS and the ATS are created. So we have prepared an example for explanation for the ATS and ATS. We have for the code list related also with the validation that was failing in the use case for the user. You have this available at this URL, and you have the ATS there and also the ATS. The relation between this slide was also shown by Marco at the very beginning. You have all the requirements which are grouped in conformance classes in the ATS and test cases, and these test cases are grouped as assertions. These assertions are, in the end, piece of code that need to be executed. So the ATS here, the main concept. Again, I'm now going a little bit fast. The ATS indicates how the ATS has to be implemented and where it comes from. You can find it, and you can see here all the lists and the multiplicity, and everything is available in the ATS. And now the ATS needs to comply to a certain structure in order to be executed and to comply with the standard. First thing, we need to, if if you remember here, we have the test case and the assertions. We need to create a test assertion with a label to name it, and with the description of the rule, a description of the rule here, and the source ATS and the links, in order that the ETF then can, in your test report, place all the content and the information available for the validation you have failed. So when you create an ETS, apart from creating the code for the validation, is super important to include also where this ETS is coming from and the link to the ATS. So you can reason along why your data or your data set or service is failing when executing this ETS. So you have to put a Xquery code and also an EID linking to the ATS. As a quick share of this would be to see here. You see an ETS for buildings. We were planning to explain a little bit on this, but we're running out of time. So you see the structure of an ETS, where we have the test driver we are using, in this case BaseX, and then we have the dependencies that we have with other ETS, and then the test module, and coming to the test case, and inside a test case there are different test steps, and then the assertions. The assertions are the requirements one by one, and this is the assertion that was failing before in the previous example. We have the label, the description, and the test step, which is related to it. And then in the expression, you have to put the code list. These are variables, and then you execute the code, checking this variable against the content that is provided in the data service or metadata. And according to this code executed, you finally have some error messages which are reported in the test report. So well, this is available as commented, and you can go through it in all the links. And it's a matter of understanding the query and going to the source code. Now we move maybe to the admin part, which is also very important because this is what we are providing as part of the releases. Okay, so assuming that you are familiar with Docker, we provide you with a command in the release to run in case you want to deploy it at your premises, and you will have it running in the port 1880. After this, you will have the validator running, and we will now go live because we will now go live. But we want to go through the whole process. We want to provide you with a better understanding of what is inside the release and what is inside the Docker zip that you find. All the components, the version, the validator var, which is the ETF var, the UI zip, which is the UI, the license, and the Docker file, which are the instructions that we provide to Docker to build the image. Also, super important to know the configurations, places in the rest folder. In the rest folder of the zip file, where we configure all the elements that we saw before: the squid, the Apache, and also the ETF and the UI. We will also tell you now details on how to build your own Docker image and the configurations that we are having for the different folders that we explained you in the past slides. This is for the configuration of the deployment of the ETF mainly, and this is for the configuration of the UI. Okay, you will have here in the corresponding file how to enable or disable the CAPTCHA, the environment, the version, where do you want to deploy it, where is your API, because you want to put the API in other place, and also configure some messages. These are also parameters for you to know, because this is a very useful case, I think, for some of you where you want to deploy the inspect reference validator in your premises. You have not only to consider the UI, but also remember that the UI uses the API. You have also the need to configure the ETF. So let's go now to provide you with some live demo with this part. Daniel.
Hello again. We are gonna be showing how to manually build an image for the validator and how to upload it in a local instance so you can use it locally. First, we will have to download the Inspire Validator version we want to use zip, and once we have downloaded it, we can extract it on any folder. Once we have extracted it, we will open a terminal and we will build the image using this command. As we can see, it will start building our image, and it have already built it. Then we can upload this Docker image using this next command, in which we have to tell Docker to use the image we just created, which is this one. And we can see it will be start uploading, and once a couple minutes or 5 minutes, depending of your machine, it will finish creating the local instance of your validator. Once it has fully loaded, we will see on our localhost port 8090 that our local instance of the validator has been uploaded, and we can access it to start testing all of our data.